Welcome, everyone. Today we are playing a high-stakes game of chess. But we aren't moving knights and bishops across a board. We're doing something much more important. We are thinking 5 moves ahead in the Cambridge Computer Science exam. I am going to show you exactly how to anticipate the examiner's next mental move. Whether you're studying syllabus codes 0417, 0478, 2210, or 9618, this explainer is going to completely transform your approach. We're taking the rote, boring memorization of sound sampling and resolution, and we are forging it into a structured, high-scoring, grandmaster-level exam strategy. Now, I want you to picture 2 students sitting in a perfectly quiet exam hall. Let's call our first student Alex. Now, Alex is a hard worker. When a computer science question pops up, Alex panics and overloads the page with raw facts. We're talking a massive data dump of everything they've ever read, but with absolutely zero analytical structure. Then there's Sam. Sam is a rusher. Sam sees the word sound and just starts frantically writing, completely missing the specific command word requirements at the start of the actual question. If you looked at their test papers right now, and we are going to visualize exactly what this looks like today with dynamic split screens and brutal red pen marks, you would see brilliant knowledge losing point after point. It's tragic. Our goal today is to ensure you are neither Alex nor Sam. By the end of this explainer, you will be the strategist.
Okay, let's dive into this. Here is the precise roadmap we are going to use to tackle your computer science exams like a perfectly logical puzzle. We'll start by disarming the memorization trap. Then, we'll build up your defensive skills using the 3 layers. We'll draw a hard line between describe versus explain. After that, we'll implement a structured solution path, navigate those sneaky exam traps, and finally, finish up with a bulletproof self-check mechanism.
So let's get right into Section 1, the memorization trap. Why learning sound sampling is just an isolated standalone definition is the most critical mistake you can make, and exactly why it loses you so many marks.
Let's start with a hard truth. Learning sound sampling and resolution as a standalone vocabulary list is going to hemorrhage your marks. Let's look at our student Alex from earlier. The exam question asks to evaluate the impact of increasing audio resolution. Alex confidently writes, resolution is the number of bits per sample. Sound is an analog wave. Boom. Period. End of thought. Alex memorized the glossary, completely fell straight into the memorization trap, and the examiner's red pen just slashed right through that answer. Why? Because Cambridge assessment objectives demand application. They literally do not care if you can define a concept in isolation. They want to see it connected to a larger web of digital ideas. So, I want to challenge you right now. Look at the question on the screen. What problem does sound sampling actually solve in a digital system? If you want to write a strong response, you must start by identifying the practical consequence. Computers, as we know, only understand binary, ones and zeros, discrete data. But the real world, like the sound of my voice right now, is a continuous analog wave. So the massive engineering problem is, how on earth do we get this continuous physical wave into a discrete digital machine? We sample it. We measure the amplitude of that sound wave at regular time intervals using an analog to digital converter. If you understand that we are solving a fundamental communication barrier between humans and machines, you instantly have a reason to learn the content. You aren't just memorizing sample rate and bit depth anymore, you are mastering the actual engineering solution that makes digital music, streaming video, and voice calls physically possible.
And this brilliantly illustrates our next core rule. Read that quote on the screen. Generic responses rarely gain full marks. That is pulled straight from the examiner's mindset. If you are floating around in abstraction, you are losing points. Computer science concepts must be applied to real situations. Imagine a past paper scenario. Let's say one question is about an organization creating a weekly podcast series, and another question is about a highly secure military database storing biometric voice prints. Your answers on sound sampling for those 2 scenarios absolutely cannot be identical. The podcast needs a high enough resolution for pleasant human hearing, sure, but it has to be compressed enough for quick web streaming. The military database, on the other hand, requires maximum bit depth for incredibly precise biometric voice verification, and they literally do not care how big the file size gets. When you apply the theory directly to phones, websites, or secure databases, you prove to the examiner that you possess adaptable functional knowledge, not just a photographic memory of the textbook.
Moving on to Section 2, the 3 layers of explanation. This is where we introduce the core strategy of building up an exam answer progressively, layer by layer, so it can actually survive under intense time pressure.
Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's get back to building that perfect answer. So, how exactly do we crack these high-level, perfectly contextualized answers? We use a core strategy called the 3 layers of explanation, and we are going to use the Peel framework, that stands for point, evidence, explanation, link, to lock those layers into place. Let's see how this builds from the ground up. Layer 1 is simple everyday language. If I ask you what sound resolution is, in Layer 1 you might say, oh, it's how detailed the audio sounds, like a high-definition TV, but for your ears. It's a conceptually great start, but in a Cambridge exam, it scores 0 marks. So we move to Layer 2, technical vocabulary. Now you say, resolution is the number of bits used to record each measurement of the sound wave's amplitude. Much better, you've hit the syllabus terms, but Layer 3 is the exam-level explanation, and this is where we unleash our Peel framework. Watch this transformation. Point, higher resolution increases overall audio quality. Evidence, because more bits are allocated per individual sample. Explanation, this allows for a much more accurate digital representation of the original analog wave's amplitude, significantly reducing quantization errors. Link, therefore, the final file size will be exponentially larger, requiring substantially more storage space on the user's device. Now that is a grandmaster move.
Which brings us perfectly to Section 3, Description versus Explanation. Let's look at some crucial boundaries and a vital teaching discipline that prevents your answers from being safe but ultimately shallow. This right here is where our student Sam usually trips up. Sam rushes, sees a key word, and completely fails to differentiate between a description and an explanation. You have to understand that the command words at the start of Cambridge exam questions are not gentle suggestions. They are strict operational directives. If the paper says state, it wants a rapid-fire fact. If it says describe, it wants the characteristics. But if it says explain, it fundamentally requires both the mechanics and the underlying reasoning. Now, what's really interesting about this slide is the stark visual contrast. The examiner expects you to master this exact boundary. A description tells what the process is. Sound sampling is measuring an analog wave at regular intervals. Great, that's a solid description. But look at the explanation side. It tells how it works and why it actually matters. An explanation sounds like this. Sound sampling works by measuring the amplitude of the continuous analog wave at set time intervals and converting these exact measurements into discrete binary values, which matters because it allows physical data to be processed by a digital computer. Do you see the massive difference there? If you look at our visual right now, the red pen marks on Sam's paper just magically transformed into green check marks. When you explain, you must provide the mechanism and the consequence.
Listen closely, because computer science reasoning relies on incredibly sharp boundaries, things like memory versus storage or data versus information. If a question asks how increasing the sampling rate affects storage, and you start writing about how it fills up the RAM or memory, you are answering the completely wrong question. Memory is your volatile short-term workspace. Storage is your non-volatile long-term saving. A higher sampling rate means you are taking more data points every single second. Think about 44,100 samples per second for CD quality audio. That directly increases the file size, thereby demanding more secondary storage capacity on the hard drive or SSD. You absolutely must avoid the trap of confusing similar sounding terms. Take a breath, read the command word, identify the specific technical boundary they are testing, and then execute your strategy.
Let's move to Section 4, the Structured Solution Path. This is where we shift focus to the actual technical execution in the exam hall. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Okay, so this is the mechanism that turns all this wonderful theory into raw, undeniable marks on paper. This is your time management matrix combined with your answering blueprint. We are going to look at the exact 4 steps that will guarantee you hit the assessment objectives every single time. Let's break down this sequence. Step 1, identify the demand. Look at the command word. Is it asking for an advantage, a process, or a comparison? Step 2, classify the concept. Okay, the question mentions audio quality, so this is about bit depth and sample rate. Step 3, the step-by-step sequence. Order matters immensely here. Explain the mechanism first, then the consequence. Don't just throw facts randomly onto the page like Alex does. Step 4, connect to context. Apply it back to the specific scenario in the prompt. I want you to imagine a complex data chart on the screen right now, showing audio bit rates.
If I gave you a 60-second challenge to extract the core trend, you'd use this exact method. By logically ordering the mechanism first, you prove deep, unshakable comprehension.
So, the absolutely crucial point here is to keep it contextual. Real-world transfer is what converts mere memory into actual exam usefulness. Let's do a quick Find the Flaw challenge. If the exam asks about implementing a VoIP, Voice over IP phone system in a super busy corporate office, your discussion of sound sampling has to reflect that specific environment. A busy office needs incredibly low latency and fast data transmission. That means they might actually opt for a lower sample rate to reduce bandwidth requirements and prevent lag during international conference calls. But if the context shifts to a high-end recording studio, they need maximum resolution and a massive sample rate to capture every tiny acoustic detail, and they completely ignore bandwidth limitations because they have massive local storage. It is the exact same computer science theory, but completely different applications based entirely on context.
We are now pivoting to Section 5, Avoiding Common Exam Traps. It's time to troubleshoot the specific surface-level pitfalls that distract students from the real ideas. Let's dive into these error-aware notes. I want you to look at the common mistakes listed on the screen right now. Vague wording, missing process steps, stating an advantage with no reason, and identifying a device without justification. Let's do a speed round. Listen to this horribly flawed sample paragraph from a mock exam. A higher sample rate makes the sound better. It uses more space. You need a microphone. Okay, stop. What are the fatal flaws there? First, it's unbelievably vague. Better is not a computer science term. You need to say higher fidelity or more accurate representation of the original wave. Second, uses more space. No, say exponentially increases file size and secondary storage requirements. And finally, you need a microphone. You are identifying a device without justifying exactly why it's needed as an analog to digital converter.
And finally, Section 6, the 4-question self-check. This is the ultimate verification stage for your revision cycle to ensure true adaptability.
We are concluding with your ultimate cheat sheet. If you look at the progress bar of your mark potential right now, it is hitting 100%. We have decoded the command words, we've applied the Peel framework, and we've managed our time and structure matrix. But how do you actually know, sitting alone at your desk at night, that you are ready for the exam? Here is the system. Write these 4 questions down. 1. What is it? 2. How does it work? 3. Where is it used? 4. Why is it better or worse than an alternative? If you can paraphrase these 4 answers out loud without relying on memorized wording from a textbook, you are officially exam ready. Let's do it for resolution. What is it? The number of bits assigned to a single sound sample. How does it work? It creates a range of digital values to represent the exact amplitude of a wave at a specific moment. Where is it used? In analog to digital converters in recording systems. Why is a higher resolution better or worse? Better for quality because it reduces quantization errors, worse for storage because it increases file size. Boom! Full marks. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder: subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
So I leave you with this final provocative thought. Are you ready to actually solve the digital problem, or are you just going to sit there repeating textbook definitions like Alex? I want you to completely rethink your entire study approach based on this blueprint. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.